Hmm. Okay, so we were where in last lecture, last session, exercise.
Seems to be completed all the questions.
Hmm? What?
I think we completed all the questions of that particular exercise.
2.1. No.
Yes,
Let's move towards now 2.2.
yes.
So here we are done. No. This other trigonometric functions. So we have completed this. Hmm. Now
Yes.
we have studied this part. Fundamental trigonometric identities, right?
Yes.
This we are now familiar with. Fundamental trigonometric identities. Now this topic, periodicity of trigonometric functions. Hmm? Now, what do you mean by periodicity? What is meaning of periodicity? Okay. Now we know this is 0 degree, right? This is 90 degree. Then here you also tell me.
सर एक सेकंड मी ऐकते कॉल येतो एकच सेकंड सर आईचा कॉल येतोय
Okay, okay. 180 degree, 270 degree.
तर तुम्ही कंटिन्यू करा
Okay. Hmm. Pay attention. See, if we start from 0 degree, vertex is at origin, initial arm is coincide with positive x-axis. This is what? Positive x-axis. Hmm? Now we are rotating terminal arm in anti-clockwise sense. Let's rotate this terminal initial arm to acquire the position of terminal arm. Okay. Now see here, 90 degree. We have rotated terminal arm to acquire the position of y-axis. Again, we rotated by 90 degree to acquire position of negative x-axis. So 180 degree angle, in 180 degree angle, terminal arm will be coincided with negative x-axis. Now again, if you rotate terminal arm in this way to acquire position of negative y-axis, and then again if you rotate by 90 degree to acquire the position of positive x-axis, but it completes one rotation. Now here what happens, this 0 degree will overlap with 360 degree. Getting my point? Now again
येस
on continuing same way, if you rotate by 90 degree, then it will be what? 90 degree, which is same as 450 degree plus 360 na. Okay. Again, if you rotate then 180 degree, it will be same as what? 270 450 plus 90, 540 degree. Again, we rotate by 90 degree, then it will be 630 degree, right? So 270 degree is same as 630 degree. Okay, and again if you rotate through 90 degree, we will again come to the original position of initial R, and its measure will be what? 720 degree. So here this 0 degree it's same as 360 degree, it's same as 720 degree, and 90 degree is same as 450 degree. Again if we rotate like this, we can complete n number of rotations. As many times as we want, we can rotate the terminal arm. Okay, and accordingly equivalent measures of angles we will be getting. In this way. Okay, now see here, this angle. Say this is the terminal arm. So here one complete rotation 360 degree, two complete rotations 360 degree, two rotations, then three rotations, then four rotations, five rotations, then six rotations. So it will be same as 6 into 360 degree. So it must be equal to 2160 degree. How much? Plus theta. Let's say this is the theta. Okay, so this portion is of theta. So this angle is theta degree, one rotation just theta degree, then it will be 2160 degree plus theta. It is same as theta. Why same as theta? Because for the ratio of this angle 2160 degree plus theta will be equal to ratio of theta. Getting my point? Hello, are you getting my point?
Yes, yes.
Okay, and hence it is repeating after this interval. How much interval? 2 pi equal to 360 degree. It is repeating after the values of, that means what? The main takeout from this discussion is the values of trigonometric functions repeats after a certain period of time. Hence, thus, these functions, these means trigonometric functions, are called as periodic functions. Understood? Why periodicity? Periodicity
Yes.
because its value repeats after certain interval, and hence these functions are periodic functions. Now here the period of some major main trigonometric functions is given. See, see, period of sine theta is 2 pi. That means what? value of sine theta repeats after 2 pi. See here, 0 degree, 360 degree, 720 degree, and so on. On continuing this way, we will be getting same values again and again. Cos theta, its period is 2 pi. Tan theta, its period is pi radian. Cosec theta, its period is 2 pi. Sec theta, its period is 2 pi. And cot theta, this value, see, tan theta and cot theta. These two ratios have period pi radian. See, only tan theta period of sin theta, cos theta, sec theta, cosec theta equals to 2 pi. Period of tan theta, cot theta is pi radian. Simply pi radian. That means tan theta, this value repeats after each addition of pi radian. Getting it? So this thing only you need to learn. You need to remember. You need to understand this. So what is period? Have you understood?
Yes, sir.
Okay. Now next part is domain of function and range of a function. Okay. So let's understand that part. Domain and range of a function. Okay, now this is domain and range. This concept is very important. It is there in detail in the second chapter, I think, of part 2, maths part 2 of 11. It is there in second chapter. Are you listening?
Yes, sir.
Okay. And this thing, the depth of this syllabus, functions, sets, relations, is very nice. It is explained very deep in HSC book, HSC board book, in details than NCRT. NCRT. It is explained so nicely in HSC book. This concept, domain and range and functions and all. Okay. So you must opt for this state board only. Okay. Now next part, domain. What is domain and what is range? Let's study this topic in short. We will be discussing this again when we study that chapter. First of all, we need to understand relations, and then we'll go for functions. So in that second chapter, we will be studying in detail the functions. Okay. Now, have you understood this? See what functions are. See, say f of x is equals to y. Be a function. This is not the proper definition of the function, but it is just an understanding what domain of a function is, what range of the function is. Okay, let's say x belongs to set A and y belongs to set B. Okay, see, what does it mean? Let's say there is a set A, say 0, 1, 2, 3, 4, and 5, and y, this set B equals to 0, 1, 4, 9, 16, 25. Okay, so see, f of x equals to y. That means what? For each value of x in the set A, that means what? We have a choice for x from set A only. All points, all values of x must be from set A. So this set is called as domain of function. Are you getting it?
Yes, sir.
Okay. Domain of a function means what? From where we are choosing inputs in the function. What? Where? Repeat after me. From where?
Yes. From
From
where
where? We are we are choosing inputs of the function.
we are choosing inputs of the function.
From domain set.
Huh.
Okay. Now,
Yes.
this set, range set. Range set is what? Set of outputs. Set of all possible outputs.
Yes.
Set of all possible outputs of the function is called domain range set. Range means what? These are the values from set B taken by the function at particularly chosen value of x. Understood? Okay. So see, in trigonometric functions, see, domain of sine theta is r. Domain of sine theta is r means what? For each real number from set of real numbers. Sine f means what? Here sine r each defined. There exists a value for each real number r. This ratio is defined. Getting it? Hello?
Yes, sir.
Okay. You please try to stay unmute so that you can respond quickly.
Okay.
That will be better. Unless I can't know whether you are attending or not. Okay. So see,
Yes,
sine
I'm attending.
sine r. For each value of r, there is a value in set B. That means what? Sine ratio is defined for all values, all real numbers. Again, the domain of cos theta is r. That means what? That means what? E cos r is defined for each real value, real number, for each real number. Understood? Okay. Now see third,
Yes.
domain of tan theta. Domain of tan theta is C. Tan theta is r minus n plus 1 pi by 2. 2n plus 1 pi by 2. Tan theta. Domain is what? r
1.
minus 2n plus 1 pi by 2. What does it mean? See, 2n is natural number. N is a natural number. Say n is equal to 1, then it will be 3. N is equal to 0, then it will be 1. So 3 pi by 2, 1 pi by 2, then 5 pi by 2, then 7 pi by 2, then 9 pi by 2, then and so on. That is what? Odd multiple of pi by 2. These values, these numbers are excluded. Excluded means what? Subtracted from set of real numbers, and then whatever is left, that is taken as a domain set. So these numbers, see, pi by 2 means what? Tan pi by 2 is not defined. It is not defined. Then tan 3 pi by 2. It is also not defined. Tan say 5 pi by 2. It is also not defined. Tan say 7 pi by 2. These values are not defined values. Understood? Getting it or not?
Yes, sir.
Okay. So this thing is there. The domain of tan theta is all real numbers except these values. This means what? R minus this 2n plus 1 pi by 2 means what? All odd multiples of pi by 2 are subtracted from set of real numbers, and whatever is left, that will be taken as set of domain. Domain means what? From that set, the inputs for tan ratio are chosen. These are definitely pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, 11 pi by 2, 53 pi by 2, 77 pi by 2, 93 pi by 2, then 1353 pi by 2. Whenever there is odd multiple of pi by 2, it is not from, or its tan ratio cannot be defined. That's it.
Okay, okay.
So this is the meaning of domain set. Domain means what? From where the inputs are chosen. Domain means what? From where inputs are chosen for the function. And range means what? The values taken by the functions for all possible inputs. For all of
Yes.
its inputs. So that's the meaning of domain and range of the function.
Okay.
So you must know what is important in it. You must know what is domain of tan, what is the domain of cot, domain of sec, domain of sine, domain of cos, etc. So this chart only is important, and rest theoretical discussion, that is quite trickier, quite confusing. So you better you avoid. Just
Yes.
if you understand the graph, then it is absolutely fine. It is very good thing if you understand the graph. Otherwise, ignore all the stuff explained in the theoretical part and just focus on this table only. Okay, and that is
Yes.
also this domain, range, and period. This thing is also very rarely used. What? What I'm saying? It is very rarely used. If you don't know
Rarely.
this thing, if you don't know this thing, still you will be able to solve many problems of trigonometry. Okay.
Okay. Okay.
But for better and deeper understanding, you must know this concept domain, this concept range, this concept period, and their values.
Yes.
What is domain of the function? What is the range of the function? What is period of the function? That must be known. So is this one clear? Now next is graphical representation. Okay, now see, you can see here the graphs are plotted. Graph of sine function. See, x y x0 y0 x pi by 6 y 1 by 2 x pi by 4 y 1 upon root 2 1 upon root 2 is 0.71. That value is converted into decimal. Pi by 3, this value root 3 by 2, this value is converted into decimal root 3 by 2. Better you check it with root 3 by 2. 1.22 divided by 2. 0.61 and pi by 6. 0. This value turns out to be 0.6123. It is in radian, no? So 5 by 3. 5 by 3, no? So these taken, values are converted into decimals. root 3 by 2 tan pi by 3. This is tan pi by 3. Sorry, sin pi by 3. It is root 3 by 2. Root 3 by 2. Okay, and its graphs are plotted. Okay, so see, this taken on x-axis, this readings were taken on y-axis, and their graphs are plotted. See, the graph of sine theta looks like this. This wave is called sine wave. Sine wave. This is the graph of sine theta. Then next, see from the table, values of cos theta are plotted, and this is the graph of cos theta. Getting it?
Yes, sir. Yes.
This is the graph of tan theta. This domain is restricted here. Okay, otherwise
Yes.
you will be getting such a parallel diagrams, parallel graphs, same type of. Okay, so this graph is of
Yes.
tan x, tan theta, or you can say.
Yes.
Any doubt in it?
No, sir.
No. Graph of sine function, graph of cos function, graph of tan function. Okay, now next part, exercise 2.2. This thing is also polar coordinates and Cartesian coordinates, polar coordinate system. Okay, I told you this thing. What is polar coordinate system? Can you see this?
Yes.
Okay, see. X-axis and this is y-axis, right? Okay, and we know what we know. See, here there is origin 1, 2, 3, 1, 2, -1, -2, -1, -2, -3, and so on. Okay, so coordinates of this point will be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 6, 4 are the coordinates of this point. Understood? Hello, are you there?
Yes, sir.
Okay,
Yes.
now see this particular point, let's express in other terms. Okay, now see this again is the point. Okay, now we have seen standard position of an angle. So if initial arm of an angle is coincided with positive x-axis and terminal arm lies in any of the quadrant. Okay, now see, let's take that point, that particular point P, whose coordinates are to be found on this what in standard position in the on the terminal arm, okay, of angle theta, where that terminal arm passes through point P, and let's say this point is at distance r unit, That means what? We can always draw a circle of radius r passing through that point P. Getting it? Getting it or not?
Yes.
Okay, so if such a kind of circle is drawn around that point, see, circle of radius r. Now it is not absolutely at the same point. This center is not at absolutely same point. So see, r is radius of the circle. R is radius of the circle, and this point lies on the radius of the circle, and it that radius is inclined through an angle theta degree. Then the another way to express location of this point is r means what? Distance of that point from origin, and theta. Theta is what? Inclination of the line segment, inclination of line segment from positive direction of x-axis, theta. So r theta is now new location. New is same address in different language or different words. Okay, that means if you are telling address of your house, right? And you said my house is opposite to that aviation college, but no one knows that aviation college, right? Then you what you will say?
Yes.
What you will say? No, my house is near to Bank of Maharashtra, near to Sinhagad College. If someone knows Bank of Maharashtra, he will arrive towards Bank of Maharashtra. He will come near to Bank of Maharashtra. Okay, and then we look for your address. Otherwise, if anyone don't know Bank of Maharashtra, will look for that Sinhagad College, and then will come towards your house, right? So it is just telling same address in another words, right? The point is going nowhere. Likewise, your house is only on that same place, but you are just telling the address in different language or different words, so that someone can understand easily that location. Okay, so earlier we were used to what? Used to denote point. Okay, earlier we used to denote the point coordinates of point y, what? X and y coordinates. Now we will be denoting the points by their position, that is how far that point is from origin, how far is that point from origin. Getting it or not?
Yes.
Hmm, it's fine. Hmm. Now see, suppose if terminal arm of the angle, is here. See, here. Terminal arm is this one. Then it is inclined through an angle theta. And this distance is r. So location of this point is r theta. Right? Suppose if the point is here, then theta will be different. See, theta will be this one, and r will be this distance, r. Then coordinates of this point will be r theta. Okay, but as I told you, you are telling your house address like it is opposite to that aviation college or near to Sinhagad college or near to Bank of Maharashtra, but your house is staying there only, it is going nowhere, but you are just telling address in a different way, right? Understood?
Yes.
Okay, so there is always a way. See, this point P is there. Now in this coordinate system you have noted location of this point as r. R means what? Its distance from origin, and theta means what? At an angle theta, the arm passing through that point is inclined. So r theta is the location of that point. But there is always x. There is always what? X and y coordinates. Okay, that is passing through that point perpendicular to, that is distance of that point from x-axis and distance of that point from y-axis, that is always there and it is going to stay constant. Okay, so that coordinates x and y coordinates are always there. Okay, so there is a relation between xy and r theta. Always there is such a relation where x is r cos theta, y is r sin theta, and we have seen this, or where while developing that fundamental trigonometric identities, their proofs, we have seen that we will consider a circle of radius r, will draw a perpendicular, and then by writing ratios, you see this here, sine ratio, cos ratio, tan ratio. From that, this value is x, this value is x, this value is y, and from that we have developed this relation. Okay, so x is r cos theta, y is r sin theta, or theta is equals to tan inverse of y upon x, and r is equals to square root of x square